Good morning all. Myself is Vigneshwari, Assistant Professor in the Department of Electronics and Communication Engineering from SNS College of Technology, Coimbatore. So today I am going to take the topic on registers from the unit sequential circuit. So this comes under the subject Digital Principles and Computer Organization. So let's recall what we discussed in the previous session. We were discussing about flip-flop and types of flip-flop, right? So it consists of SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. So basically we discussed what is a flip-flop. It is a 1-bit storage register, and for specific type of application we will be using those different kinds of flip-flop JK, D and T. And today the topic for discussion is we are going to discuss about registers. Why do we need register, its type and its application? So why do we need registers? So registers in flip-flop will be able to store only one bit of information. So that is properly organized and in sync with the clock pulse. But computer it does many data processes, right? So we need some data to be stored temporarily for performing certain arithmetic and logical operations also. So where do we store all these bulk kinds of data as such? So for that we need the registers. Since flip-flop is able to store only single bit, here we are going to store a huge amount of data. So multiple bit storage, it requires the proper registers, right? And that registers it also should be in synchronized with the clock pulse as such. So as you can see, there is a balance between the storage capacity and also the complexity how to deal with those registers as such. So flip-flop it is a single bit storage and it has very simple, but registers, when we look into registers, it is of a multi-bit storage and it has few complexities also. So a register is a collection of a flip-flop which is being used for storing the multiple bits. And as I said, this is in sync with the clock pulse we apply. And the shift registers also we are going to discuss. What is that shift register? It is able to shift the data either parallelly or serially. So how does a register store the data? So first we start with an empty register where it doesn't have any data as such, and then once the clock pulse is being activated, it starts to store the data. So the data inputs are being obtained, that is the bits are being written onto the registers as such, and it starts to shift those data. And once all those data are being received either in serial or a parallel, it just starts to move to the full registers as such. So what are the types of registers? So registers are of four types: serial in, serial out shift registers, serial in, parallel out shift register, which is SIPO, and then parallel in, serial out shift register, and then parallel in, parallel out shift registers. So totally there are four types of registers: SISO, SIPO, PISO, and PIPO. So here I have given a sample of a serial input and parallel data output also, and you can connect this figure with all those four types of registers. Here LSB it specifies the least significant bit and MSB specifies the most significant bit. And as you can see in the figure, the serial data input is being given and the data will be moved one after the other, and that is why we say as a serial data output, because only one bit of data has been obtained at a time. Whereas in case of a parallel data input, you are going to load the data parallelly and you are going to obtain the data parallelly at the output side. So first we start with serial in, serial out shift register. So as you can see from the figure, the SISO register, the bits are being moved only one bit at a time, right? So here one bit is being moved per clock pulse, and at the output side also only one bit is let out at the clock pulse. So serial input, serial output is said to be SISO register where data being shifted only one bit at a time, and the output is also be obtained for only one bit of data. And this register is effective in data transmission system, that is for simple delay application you can use this SISO register. Next comes with the SIPO register, that is serial input and parallel data output, where you are going to give the data one by one and you are going to retrieve the data at the output simultaneously. right? So once the data enters the serial input, the data being collected at the output at the time all the four data bits are being collected. So this converts the serial mode of communication to parallel mode, and hence this is being used in the communication systems specifically for the receiver end. And next comes with the parallel in serial out register. Parallel in serial out. This indicates the data are being loaded at the time simultaneously when the clock pulse is being given. All the four datas are being loaded into the shift registers at a time, but at the output end will be collecting only one data per clock pulse. So it could receive the data only one bit at a time. So this converts from parallel to serial mode, and hence it is effective in the transmission sector in the communication system. So this is used in communication transmitter sector. Next comes with the parallel in and parallel out shift register. So data are being loaded parallelly and you're going to retrieve at the output in parallelly all the four datas. And this has been effective in used in central processing unit and for the memory sectors also. And where do we use all these kinds of registers? So this registers, as we discussed, SISO is used for a simple delay application, and parallel serial input and parallel output been used in the communication receiving sector, that is universal asynchronous receiving transmitter, and parallel in serial output for the UART transmitter sector, and parallel in parallel output for the microprocessor or microcontroller registers, and then ALU processing sectors. And this has been used in the industrial sectors of Intel processors, Siemens Automation, Qualcomm, and for the communication sectors also. So we have discussed about registers. What is a register? It is a group of flip-flop for storing the multiple storage as such, and the types of shift registers: SISO, SIPO, PISO, and PIPO. So now the curiosity challenge, right? So now a 4-bit SIPO register, it receives a serial data input 1011. So how does the data shift with each clock pulse, right? So we have discussed the answers in this. So kindly go through the video. Thank you.